to the talk. Patrick Römer will talk about creating a sensor network for measuring nitrogen dioxide. The talk has come about in cooperation with Dr. Niels Seidel from the University of Hagen in the Institute for Cooperative Systems, and it was based originally on a bachelor's thesis, and the goal is to create a completely covering measure network that is much bigger and perhaps also better than the national measuring network. A warm welcome, please, for Patrick Römer. Hello, my name is Patrick Römer, as you have heard, and I will introduce you to the sensor network for measuring nitrogen dioxide. And I start with an introduction of the toxicity and the problems with nitrogen dioxide, and what are the measuring methods, and I talk about creation and calibration of a measuring station, and I talk about sensors and choice of sensors and how we build them and what the problems were. And in the end, I will show you some results of the measurements and how we collect measurements. And at first, nitrogen dioxide, what is that? It is part of the nitrogen oxides, the oxides of nitrogen, and is a combination of nitrogen and oxygen, a compound. And there are natural sources for that by bacteria in the soil, for example. But in towns, most of the nitrogen dioxide is created in the combustion chambers of engines. Normally, that will create nitrogen monoxide at high temperatures, and is a compound of nitrogen and oxygen. It creates nitrogen monoxide. It is metastable, and although you put energy in, it doesn't decompose by itself, but it remains as nitrogen monoxide in the atmosphere. But then with ozone, it combines to nitrogen dioxide, which is the toxic gas that we are talking about. And the legal situation is at the level of the European Union in the Air Quality Directive 2008/50 EG, and there are minimum requirements for the European Union, and this minimum requirement, they were converted into German law with the 39th emission regulation, and in this regulation there will be limit values based on WHO recommendations, and there's a mean value for human health for 40 micrograms per cubic meter for during 1 hour. The mean value can only be 200 micrograms per cubic meters, and if you have that for a longer time, there will be an alarm, and the agencies will look into it. And if there's an alarm level that is 400 micrograms per cubic meter, which immediately raises an alarm, and there's an annual mean value for the protection of plants for 30 micrograms per cubic meters. And the biggest problem is, of course, for human health, and there are data from official measuring systems, and the mean value is the thing that causes the most human health problems. And for methods, there are quality standards for fixed measuring points. Those are the ones that you know. They're here, for example, at the railway station in Leipzig, there's one, and there's an orientating measurement, and there are model calculations, and there are objective estimates, which may have up to 75% error, and calculations up to 50%, and measurements 15 or 25%. And this national regulation in Germany also regulates other toxins in the air, and has some other limit values for that as well. In the 39th national regulation for nitrogen dioxide, and the measuring method is the chemical luminescence system, and there's a system by the company Teledyne, and nitrogen monoxide is being combined to NO2 in a ultraviolet chamber, and the light emissions then is proportional to the concentration.
And the gas is used with a catalyst and is combined with ozone to NO, and this you will eventually measure. And the process is quite specific, has a little influence towards external noise, and that's why it's used effectively. And one such instrument is quite expensive, and therefore it's rarely used because you need additional steps for processing the gas. First it's cooled, therefore it uses moisture. Afterwards it is heated up such that the reactions in the analytic chamber are used sufficiently fast, and therefore it has therefore it has a lot of processes. An alternative process is the so-called passive collectors. They are used for long-time average measurements. They are small tubes which are filled with a chemical. After time, it just accumulates inside the tube NO2, and afterwards they are processed in laboratory, and based on the collected NO2 values, you can estimate the average NO2 over the respective time. And this has usually about 20% of error. Yes. The official measuring networks is controlled in this law. So the measurement positions should be placed at the positions where the most values of gases to be expected. They should be representative for other places which are close around. So the idea is that if you place it at one position which has a high traffic impact, should be representative for other places with a similar amount of traffic. So the question is, if you're not living next to a big street, the question is, what is the air quality close to where I live? So in Leipzig, for example, there are only 3 places where such measurements are taken, and all the other surrounding areas do not have any installed measurement stations. So the question is, if I'm living somewhere down towards the lower right, what's the concentration of NO2 close to my home? Based on that, I have formulated the requirements for citizen science measurement station. So one is that it should be as cheap as possible, because nobody wants to spend tens of thousands of euros to place such a station at home. I mean, it would be nice if you have so much money, but well. So you would like to have good and free components for such stations. Usually, the components you have are only available for industrial players, but we want it to be widely available. It should be easy to build such a station, and ideally it should be as precise as possible, because eventually you might want to go to a government, to an official spot, and therefore we would like to stay within the framework of such orienting measurements of 25% of uncertainty. So what are the components I have chosen? As basis, we have chosen ESP32. It has an integrated Wi-Fi, 4 megabytes of flash space. I have selected an MICS metal oxide NO2 sensor, costs about 16 euros, available in the internet. It's available as a breakout board, so you don't even have to solder. Just put it onto a plate. I have chosen DHT11 or DH222 temperature and moisture sensor. And the reason for this is because the measurement you are taking are usually dependent quite a lot on temperature and moisture, and therefore you need to measure those as well and find some methods to extract them from the measurements you have taken. On top of that, you need a few resistance, and that is it. So that's just a measuring station on a simple platine. You don't really need to solder. And
so it's a very simple breakout board, and so you don't need a PCB. And so what's the probe actually measuring, and how is it working? It's a resistive sensor, so it's a metal oxide sensor, and it changes its resistance with the change in concentration of NO2 in the air. And there's a graph there for this from the datasheet, and you can see that it has a double logarithmic scale, and the NO2 concentration can be seen here in this graph, and there's an influence of nitrogen monoxide of NO and of hydrogen, and normally you don't have any hydrogen in your environment. You shouldn't have it, at least, then you should move somewhere else, because hydrogen is very dangerous and explosive. And the first thing I did was to look at what the datasheet says is actually true in reality. So what does the sensor do actually? So during 1 month, I ordered several sensors and tested them, and this is the simple installation. Here you can see this is an desiccator, and normally it's used for drying things. And the second is a gas mixer, and have several different concentrations of NO2, and I mixed it with a zero gas without NO2 in it, and the sensors or the measuring station in this container, in this atmosphere, and exposed it to this atmosphere. And it showed that the sensor, they all had more or less the same reaction, but shifted on the y-axis. And this is so it's about the converter, the analog digital converter output, but you can see that you can live with this shift on the y-axis, and it's pretty good because it makes the calibration much easier. If you convert it to the scaling that has been given in the data sheet, and it's more or less what you would expect or what you would hope for if you look at the data sheet and then have the results here. And the next step were to filter out the influences of different values, for example, the temperature. And if you have an influence of your temperature, how do you do that? If you test a thermometer where I work, and then the thermal sensor, you put it into a block and heat the block and let it cool down, and you measure the temperature and compare it to a reference thermometer. And normally we don't have 250 degrees, so the simplest solution was a styrofoam box with ice in it, or with cooling elements, and the stations were put into this cooling box, and it was sealed hermetically, and the concentration of the gases in the box shouldn't change because it was really sealed, and the only thing that changes over time will be the temperature. And the result of this was a relatively linear connection. And if you don't really want to measure NO2, then you can perhaps use it to measure temperature. But there's a connection shown here between the straight lines here. They have more or less the same slope. And then I did a calibration measurement to compare it with the analyzer shown at the beginning, the chemical luminescence sensor. And that's what it looked like. And I pulled in air from the outside into the excicator, and through the excicator and into the measuring system, into the measuring device. The measuring device is shown as number 1, and the excicator is number 2, and 3 and 4 are the computers recording the data. And it showed during several days which are these clouds of points here. The best NO2 influence had some influence on the measuring value. I chose some values where the temperature only was within a very small range, and the moisture was also in a small range of values, and the NOx concentration also were within the same region. So even during several days, you get this calibration function, and if you correct the values for temperature from the function that I've measured before, then it shows a little bit. It looks a little bit better, but it shows a big problem here. There's this nitrogen monoxide and nitrogen dioxide are not available, are not contained in a fixed ratio, and NO is created in the engines and then changes into nitrogen dioxide. But the influence of nitrogen monoxide is reverse of that of nitrogen dioxide, and it's pretty bad because now before really you use the measuring station, how could we remove the nitrogen monoxide? So this is the influence of temperature. We looked at that again, and it's very similar here too. There's a cloud at the end. This is caused by the fact that the range of temperatures is just a few ppb, and well, yeah. But it also showed here that the connection to the temperature was the same as found out before. And so I'll recap the problems here. The influence of NO2 and NO is reverse, and it would be nicer if it were in the same direction. Then the NO influence would be much lower. And NO2 and NO2 don't always show up in the same ratio. So if you have a measurement of X, then we need to have NO2 at 100 ppb, and the other maybe 80 ppm or ppb, depending on what you have. So, but the ratio is not always the same. So, and since we have no way of measuring NO separately, there you can only really change NO into NO2, for example, with an ozone generator from the aquarium supplies, or with an oxidator like potassium permanganate. But this would increase the complexity, and this is the problem that I'm working on at the moment. Well, yes. And if the measuring station works now, the next step will be to create a measuring network. If I've done the tests with the ozone generator, then I will start creating the measuring network. And so what are the requirements of the measuring network? It has to be a very high availability, and the sensor should ideally not break down after half a year. It should have very narrow meshes, and so you can show temporal connections. For example, if you have a combustion somewhere and that creates a huge cloud of NO2, and then I want to see on the map how it spreads. And so the distance between measuring stations should be low, and ideally, and you could then figure out defective sensors if they're close to each other, and you can put it into places that are far away from the official measuring stations. And what is important is to know the error of the measuring station. And so no data is better than poor data. So if you really want to do something with the measured values, you have to know what the error is of the values that you have measured. And you need to have a way to collect and retrieve the measured data.
Okay, and from these measurement data, there are a couple of ways you can visualize them. So, for example, the first one above is the heat map. Starting from a point which creates a colored surface. Other points in the surroundings color the surface appropriately depending on the measurement value. Another option is the hex bin map visualization on the lower left. The surface is divided into regularly sized hexagons, and they are colored depending on the concentration in the respective area. A problem is if the measurement station is on close to the border of such a hexagon, but the rest of the hexagon actually has a low concentration, and therefore this can change and visually alter the representative visualization. And the other option is to just pin appropriate spots with the measurement values, which is easy to give an overview. So I have programmed a platform for this, which is called OpenNox. It's a web application with the instructions how to build the measurement stations. Well, including the measurement station would have the problems in order to, which doesn't have the ozone generator yet. It has an option to register your own measurement stations, and there's an API to send and retrieve the current and historical measurement data. The source code for the measurement stations in the web applications are on GitHub. And if somebody has some idea to improve the way I analyze the measurement data, I'm very happy to contribute. Right now, there's also an API to include the official measurement stations of North Rhine-Westphalia, but unfortunately, every state of Germany here does use a different way to provide the data, and therefore it's very difficult to generalize this for the rest of data. Right now, OpenNox still links to the GitHub repository because I have some trouble with the provider at the moment. But that's how OpenNox looks like. You have the map with the measurement data. So this is Mönchengladbach. The green thing here is the official station on the street, and the blue dots are our own measurement stations, which right now only provide raw data. There's the instruction list with the component list to build the board. Because, well, building the board yourself and extending the board yourself, I mean, there are a couple of ways you could extend or include extra features. For example, ways that send the data automatically, or something which stores the data on the USB stick and transfers the data at a later point. Outlook, what is there to be done? So the biggest problem is the cross sensitivity with nitrogen monoxide. That's one of the things where I'm currently working on. So my idea right now is to work with ozone in order to completely change over the the nitrogen monoxide to nitrogen dioxides. So the idea is that you can use this as input to a calibration function to retrieve the raw NO2, the complete raw NO2 value. Of course, another thing is to spread the word. That's what I'm doing right now, and based on that, build a whole measurement network, and with this, maybe identify other NO2 producers which are currently unknown, maybe in a way. And of course, last but not least, to extend the board by additional sensors and additional functions, for example, to be mobile and mobilely measure the data and send it over at some later point. So that's pretty much it. Many thanks for your attention.
Yes, and that has been the translation of the talk, creation of a sensor network for measuring nitrogen dioxide. And we were MFH and Pink Dispatcher. There are two questions. How many measuring stations are there already at OpenNox? And the other is, wouldn't it be better to have a better temperature sensor? Would that make sense? It's only a little bit more expensive.
How many are there? Well, since we're just starting right now, basically one. One by myself. The temperature sensor. The influence of the temperature is pretty much linear. So a better temperature sensor, is something one can use, and maybe that's a useful in the future. But what you've seen so far, it's sufficient as it is. So basically, you're just you're just determining a 0 for this measurement station, and it's basically sufficient to only know that there has been a change by temperature by 1 degree. And for the normal measurement stations, where the temperature changes only about 20 degrees, it's kind of sufficient. So yeah, but if there's something better, why not?
It's from the internet, please. From the internet, there was the question if an integration or cooperation with Luftdaten.info, because they're doing basically a similar thing. And instead of having so you could have one for NO2 and one for aerosol and measure different things.
Yeah, I I wrote to the mentioned website, but I didn't really get an answer. So somebody's waving, so maybe that's the answer.
So we are from Luftdaten.info, the three of us, and we are working on a theme like that. So it was very, very interesting. Thank you very much for the talk. And we would really like to cooperate. And we would like to announce that we have a sensor community that is a platform, and it's only air data quality for aerosols, but and it's also for a big European campaign, as it has been successful in Belgium with passive sensors. And we are coordinating the institutions, and it was a very good talk. Thank you very much. And
yeah, maybe we want to talk later. Yeah. Okay, you can continue this later. We'll continue with the questions. Do you know how stable sensors are in the long range? Do they keep showing the same value with the same concentration in the air?
There's a way that poisons the sensor. So some gases will damage the sensors permanently and make the measuring much worse. And I have been using one for 5 months, and it didn't change a lot. But I'm living on the second floor, so it doesn't really get that many pollutants as it would be on a big crossroads. So it depends on the individual situation. So yeah, it's hard to say. Maybe 5 months. 5 months will be okay.
Microphone number 1, please. Thank you very much for this very interesting talk. We have seen in the beginning that the measurement curves all look very similar, but are just slightly shifted. Do you have a good idea how one could calibrate that simply without having a 20,000 euro device to calibrate against?
Yes, and if you assume that they may have a certain deviation, a certain error, then my hope is that at night there's perhaps there's 10 ppb around, so 5 micrograms of NO2 in the air, or NO, and then you create a 0 point and then shift the 0 point. That's something that you could try to get a daily recalibration to figure out if the sensor has big fluctuations from what you would expect.
Is there maybe... Please, no dialogues. You may answer.
Of course, you could go and do a test gas to use that. So maybe it's if it's in a pot or in the atmosphere, but usually you don't have a test gas at home. So maybe doing that at night and creating the 0 point from that is perhaps a good idea. And it's good that they are only shifted on one axis, so there's a way to do something.
Signal Angel, please. Why do you only want a measurement value for NO2 and not for NO2 and NOx? Aren't all nitrous gases problematic?
Nitrogen dioxide is especially problematic because it is water soluble, and it's one of the main solutions that causes the increased mortality. And these professional devices also measure nitrogen monoxide and nitrogen dioxide, but this sensor can only measure one, right? Okay.
Ein Hinweis, bitte redet deutlich in die Mikros rein. Also nehmt die Mikros nah an den Mund.
A remark, please speak into the microphone
properly.
properly. Microphone 3.
Servus.
Hi. Thank you very much for your presentation.
So Art bei der Kryptographie gibt es so Krypto-Partys.
For cryptography, there are crypto parties, so maybe we should have a calibration party for such sensor.
Ja, das wäre vielleicht auch eine Möglichkeit, wo man dann die Konzentration einstellen kann. Ja, das ist eine gute Idee. Yeah, good idea. Yeah, perhaps that would work.
Microphone 2, please. Hi.
Es gibt ja noch, also du verwendest ja resistive Sensoren.
You are using resistive
Es gibt ja noch
sensors.
antiresistive Sensoren, die
Alternatively, one could use
für
anti-resistive
CO2
sensors, for example, for NOx,
optische
and
Sensoren,
which are sensitive for
die nur
NOx and
für
NO2 at the
CO2,
same time. And then the optical sensors, which are only sensitive for NO2. So maybe for using a calibration chain, one could calibrate the sensor.
No, that wouldn't work. And that's the reason is there are optical sensors, but they cost 100 to 200 euros. Well, yeah, show me the one for 30. Yeah, okay. Afterwards. And there are these electrochemical sensors, which also have cross sensitivities and are also more expensive, 130 or 150 euros. And that's why I decided to use this resistive sensor. And a calibration chain of CO2 to NO2 is not possible in this way because it is in a single measuring cell, perhaps, but there are different measuring elements. There need to be different elements for measuring, to measure different values. But please talk to me afterwards.
Mikro 1 bitte.
Next question, microphone 1, please. Thank you for your presentation.
Ja, bei Luftdateninfo gibt es da beispielsweise
For
auch,
at
einige
luftdaten.info,
Schwächen bei der Feinstaubmessung.
you have a couple of issues regarding the particle measurements with respect to moisture. So I haven't really paid fully attention. Have you thought about that moisture and temperature sensitivity?
The problem is I don't have a climate chamber to simulate different moistures and create different moistures. I've tried to make comparison measurements with different moistures, but unfortunately the moisture was only in a very small range and very low, and there was a correlation, but it wasn't really enough for this. And I have to make more tests to see how it is connected.
Okay, danke. Ich befürchte, da könnte es noch mehr Probleme geben.
I feel there could be more problems.
Und noch eine Frage aus dem Internet, bitte.
Question from the internet.
Ja, die Frage kommt nicht aus dem Internet, sondern von mir selber.
The question is not from the internet, it's from myself.
Der Preis der Station besteht ja jetzt aus den einzelnen
The
Komponenten.
price of the station you have mentioned, is it all the components? Yes, it is.
In Deutschland
Wouldn't it be cheaper?
oder irgendwas zu
Wouldn't it be
benutzen,
cheaper for the mass usual in Germany to instruct a PCB deliverer? Couldn't that be also supported from the government, such that it could be distributed to the people from the government?
Yeah, don't really have any experience with getting grant money from the state, but of course that would be an option to make a PCB if we would start mass production, and you may have PCBs made quite cheaply. That's something you could do, but I haven't done that yet.
Eine Frage von Mikro 3 bitte.
Question from Mike 3, please. Is there an influence from the height where the measurement stations are placed with respect to the nitrogen content? Is there some influence with respect to where it's placed on the street, and is there a way to calibrate that back?
Yes, that's the case, and that's a very important point. If I have green plants at the street and I've measured behind the plants, there is a big difference, and there's a discussion that the measuring stations were too close to the roads, put them farther away because the distance has a very big influence. And it's a really important point with the sensors. It needed to be part of the information that something like I live on the second floor because the air will be cleaner at higher elevations than at the ground, and that's one additional information that needs to be part of the information.
Mikro 2 bitte.
Next question, Mike 2, please. I just wanted to comment Matthias and me are on a project which is called Open Air Cologne, and we are doing a sensor solution with a mix of ESP correlated to location, also with respect to particle sensors. It's also now used from a Helmholtz project to correlate this with health data. Maybe we should talk later.
Yes, yes, I'll be here afterwards.
For further discussion, information is placed. Please do it later. But right now it's for questions. Please. Micro one, please. What do you think? What do you think if you're additionally building an oxidation into the project? Is it then maybe possible to do a measurement with oxidation and without oxidation, and using that you could have a ratio between NOx and NO2?
Yes, that is exactly the plan, and that is exactly what the professional devices do. And they will oxidize, or first they measure NO alone, because they selectively measure NO, and then afterwards they measure NOx by oxidizing the NO to NO2 and then create the difference. And if you have the NOx value and know how much NO and NO2 is there in total, then you can, from the second value, you can calculate back to the first, and you have to change all the NO2 into NO.
Another question at mic 2, please. How can you only measure NO?
The measurement of NO alone in these professional devices.
Is it cheaper? Is there resistive sensors only for NO?
No, nothing that I have found would be cheaper. I might be wrong, but I have not found anything that would be affordable.
Any further question? Maybe from the internet, Signal Angel? No questions here. Okay, that's it. That was it from the C3 Lingo live from 33C6. Thank you very much. On the mic were NFH and
Pink Dispatcher.